Hi friends, here in this video we are going to see a problem on strain energy. For that, here is the question. I'll read the question and write the data along with it. A vertical steel bar 15 mm diameter, the diameter is given. So I'll find the area here itself and it comes out to be 176.71 mm square. The area of the bar. It is 1.4 meter long. Length is given. I'll convert it into mm by multiplying with 1000. Then it is provided with a collar at the lower end that I'll explain it onto the diagram. Find the maximum weight. We have to find the value of W that can be dropped through a height of 95 mm. So the height of fall of the load is given, and whenever the height of fall is given, it means it is a case of impact loading, that is the load which is falling from a height. So I'll mention the type of problem here. It is related to the impact load. If the maximum permissible tensile stress, that is also called as the maximum instantaneous stress in case of impact loading, 150 megapascal, so it is 150 Newton per mm square. Take E value, which is the Young's modulus, 200 GPa, that is 200 into 10 raised to 3 Newton per mm square. So this is the question in front of us. Now let us get started with the solution part, and in the solution first I would be drawing the diagram for the given condition. So here is the diagram for the given condition. There is a rod having diameter D, its value is given, which is 15 mm. Then at the end of the rod there is a collar. Now an unknown weight is falling onto this collar through a height h, that height is given as 95 mm, and when this load falls onto the collar will extend the rod. As we can see here, it is going to get extended, and then we are going to get the maximum instantaneous deflection. At the same time, the stress which is going to be introduced into the bar or the rod, that would be called as the maximum instantaneous stress. So first I'll write the formula for the maximum instantaneous stress, and we have to remember that W is the unknown here, which we have to calculate. How much is the amount of load falling onto the collar? So since for impact load the maximum instantaneous stress is given by this is the formula, where W is this unknown weight, A is the cross-sectional area of the rod or the bar, capital E Young's modulus for the rod material, H is the height of fall, and L is the length of this rod. Now for simplicity, since we want to calculate the value of W, sigma max is given. I would be replacing W upon A by a term called as X. So here, therefore, let W upon A is equal to X. So on simplification, that is putting all the values in equation 1, sigma max, maximum instantaneous stress, is given as 150 Newton per mm square. W upon A gets replaced by X plus root of W upon A whole square, it means it is X square, plus 2 into Young's modulus 210 raised to 3. W upon A is nothing but X and H value is 95. I'll write down X in the numerator divided by L, because W upon A whole has been replaced by X. So in the denominator only length remains, and the length of the rod given is 1.4 meter, that is 1400 mm. So therefore 150, I'll bring this X onto the other side, so it becomes 150 minus X root of X square, plus now this coefficient, which is 2 into 210 raised to 3 into 95 divided by 1400, this coefficient comes out to be, my answer is 27.14 into 10 raised to 3. That is the coefficient of X. Now in order to find the value of X, because once X is known, area is known to us, we can multiply both of them and get the value of the unknown load. I would be squaring on both sides to remove this square root sign. So therefore, squaring on both sides, on left hand side we have 150 minus X, that will become whole square, and then this entire root sign would be eliminated and we have the term inside the root sign which would be left. Here I would be expanding this bracket by using A minus B whole square, so it is A square, which is 150 square, and the answer is, I'll just go on simplifying, 150 square, it comes out to be 22.5 into 10 raised to 3 minus 2AB, that is 2 into 150, which is 300, X plus X square is equal to, here we have X square plus the coefficient into X. This has been expanded by using A minus B whole square. So we can see that from both sides X square term gets cancelled out. Therefore here we have 22.5 into 10 raised to 3 on one side, minus 300 when it goes onto the other side, that is minus 300x will be added to this x term, and the answer is 27.44 into 10 raised to 3 x. So therefore x value will come out to be 0.82. After getting x value, I'll say that resubstitute x is equal to W upon A. So therefore W upon A is equal to 0.82, and therefore W will become 0.82 into area, and area we had calculated, it was 176.71, and the final answer of W comes out to be 144.90 Newton. Hence the unknown weight which falls onto the collar is of 144.90 Newton value. So we have found out the value of W, which is the unknown load which is falling onto this collar, and with this the problem gets completed. And at the end, if you'll find my videos helpful, you can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.